200 million. That is a number that can make us pause in absolute silence. 200 million is the number of steel oil drums discarded globally in just a single year. If we laid them end to end, that rusting ribbon would wrap around the earth, not just once, but 15 consecutive times. Look at the massive scrap yards scattered on the outskirts of every civilization. These hollow metal corpses, which once held millions of gallons of lubricating oil for the global economic machine, now lie there, crushed, deformed, coated in thick, toxic chemical residue. Under the scorching summer sun and the acidic rains of winter, they oxidize, slowly decomposing in a terrifying stillness. In the eyes of most of humanity, that is the cruel end of an industrial life cycle. It is waste. It is a colossal burden that this planet is forced to carry. But nature always has its own laws, and so does metallurgy. In the eyes of material masters, metal never truly dies. Steel is one of the very few substances in the world that possesses an ultimate privilege, the capacity for immortal rebirth. And you are about to witness a true miracle of modern civilization. No visual effects, no embellishments. Only harsh reality and glorious reincarnation. Today, we will take you deep inside one of the greatest forges of the 21st century. A place where what was once considered the dregs of society, the filthiest scrap, will be forced to walk through a crucible of fire at over 1,600 degrees Celsius, only to rise from the depths of those ashes and molten magma, reborn, shedding their past to become ultra-high-strength alloy steel rails, the steel arteries of the earth. They will bear the weight of thousands of tons of freight trains, connecting desolate lands and reshaping the future of mankind. Let us step back into the past for a moment, to turn the sweat-drenched pages of heavy industry's history, to understand who the men were that turned this alchemy into reality, and how a piece of scrap waste can become the backbone of an entire world. The shape of the modern world we live in was not drawn with ink. It was carved into the Earth's surface by railway tracks. But to achieve the flawless design and absolute durability we see today, history had to learn lessons paid for with immense time and blood. Let us return to the early 19th century. Humanity's first rails were cast from iron, a hard but incredibly brittle material. Under the continuous strain of primitive steam engines, they cracked and shattered like massive shards of glass, leaving tragedies in their wake. Until 1836, an English civil engineer named Charles Vignoles brought an eternal silence and safety to the iron wheels. Staring at the shattered iron rails, Vignoles designed the flat-bottomed rail, a classic design with a cross-section resembling an inverted eye. It was not merely a drawing. It was a terrifyingly perfect calculation of physical mechanics. The base was widened to grip securely and distribute force down to the wooden sleepers. The middle web was made thin to minimize material mass, and the top head bore a flawless curve to perfectly embrace the contact surface of the train wheels, neutralizing friction and enduring the repetitive stress of millions of tons. Nearly 200 years have passed, countless technologies have evolved, but Vignoles' cross-sectional design remains, virtually unchanged, as an eternal monument to perfection. However, a great design was not enough. The source of the material was the most daunting enigma. Extracting iron ore from deep within the earth, smelting it in massive coal-fired blast furnaces, demanded a horrific devastation of the natural environment. Humanity needed a way to resurrect what was old. The man who provided the key to decipher that enigma was Paul Héroult, a French chemical engineer. In 1900, he successfully invented the electric arc furnace, EAF. Héroult did something his contemporaries considered magic. He did not use coal. He did not use firewood or oxygen to melt metal. He used lightning. By sending extreme high-current electricity through massive graphite electrodes, he created a contained artificial fire, a silent plasma arc carrying temperatures equal to the surface of the sun. This monumental, smokeless, and quiet invention by Héroult laid the foundation for today's massive steel recycling industry. He granted humanity a profound power, the power of reincarnation. And now, in the midst of the 21st century, let us witness how beautifully and ruthlessly that power is executed. The process of rebirth never begins with gentleness or ease. To completely shed a filthy past, these scrap drums must pass through the most ruthless purgatory modern mechanics can forge. Thousands of rusting drums, filled with lubricating oil residue, peeling paint, and stagnant industrial chemicals, are hoisted into the air by a colossal electromagnetic crane. They hover for a moment before free-falling into the maw of a mega-shredder weighing hundreds of tons. Inside this dark machine lies a matrix of razor-sharp alloy steel gears, rotating with torque so immense it could chew up an intact truck in mere seconds. The silence of the scrap yard is officially torn apart. In the darkness of the machine, the groans of metal cry out. The bodies of the drums are ripped, shredded, twisted, and pulverized into shapeless fragments no larger than a hand. Every physical structure of their former life is obliterated, but metal only truly holds value when it is purified. Emerging from the shredder, the sharp fragments continue their crawl along a vibrating conveyor belt. Here, they enter an ultra-high-pressure washing chamber. Jets of water slash down like blades, combining with biosolvents to mercilessly strip away years of stubborn grease and toxic paint residue. Every ounce of filth is collected and isolated into a closed-loop treatment system, ensuring not a single toxic drop escapes into the groundwater. Once cleansed of the mud, the soaking river of scrap steel passes under a magnetic separator. A massive electromagnetic drum rotates slowly above. Acting as a silent judge, it glides over the waterfall of scrap, gently but firmly lifting only the purest steel fragments into the air. Meanwhile, dirt, plastic, rubber, and other non-magnetic alloys are left behind, falling into a secondary sorting system below. At this moment, on the conveyor belt, what were once blackened, filthy drums have shed their skin to become a pure, raw material, sparkling clean under the factory's high-intensity lights. They have washed away the sins of the past, ready to face the fire of the gods. Thousands of tons of pure scrap steel cascade with a roar deep into the chest of the electric arc furnace, EAF. This is a cavernous space where the laws of solid-state physics are about to entirely collapse. As the ultra-refractory ceramic lid slowly slams shut, darkness descends. From the ceiling, 3 massive graphite electrodes, each as thick as the trunk of a century-old tree, slowly lower toward the surface of the scrap mountain. And then, a current carrying tens of thousands of volts, harboring enough power to illuminate a bustling city, is unleashed in a millisecond. An electrical arc, a blinding artificial lightning bolt, strikes the very heart of the metal. Amidst the silent, chest-rattling groan of electromagnetic energy, there are no burning flames. Yet the temperature inside the core instantly skyrockets beyond 1,600 degrees Celsius, surpassing their natural melting point. Even the most stubborn steel fragments must surrender. They collapse, melt, and merge, abandoning all former molecular structures to become a brilliant, boiling lake of metallic magma, glowing with a blinding yellow-orange hue. But the steel meant for railway tracks cannot merely be ordinary carbon steel. It must be a flawless entity, capable of withstanding the most extreme pressures and brutal wear. This is where the microscopic alchemy of modern metallurgy begins. Engineers do not rely on magic. They manipulate digital consoles. They gently introduce incredibly pure compounds into the magma, calculated down to the thousandth of a gram. A specific measure of pure carbon is added to forge absolute hardness. A touch of manganese is dissolved to enhance endurance and ductility, preventing fractures in sub-zero climates. A precise injection of vanadium refines the microcrystalline structure. Oxygen bubbles and floating slag impurities are entirely swept away by blasts of argon gas. From a pile of rusted waste, the machine has refined the purest metallic bloodline. The fiery liquid steel is poured slowly, smoothly into the continuous casting molds. It flows downward, gradually solidifying to form perfectly square, dense steel billets. Even in their solid state, they remain glowing red, emitting a fierce thermal radiation that warps every beam of light around them. The soul of the railway track has taken form. Now, it is time to shape its body to carry the world. steel billets, dozens of meters long and still holding heat exceeding 1,000 degrees Celsius, begin to glide smoothly along silent steel rollers. They head straight into the heart of the rolling mill. Here unfolds a grand dance of brutal power and microscopic precision. The glowing red billet is fed between a series of massive, ultra-hard alloy rolling stands. With each pass through a narrower gap, a hydraulic force of thousands of tons gently kneads, stretches, and permanently alters its structure. From a crude square block, the steel is gradually pinched at the waist and flared at the ends. Slowly, the silhouette of the inverted eye cross-section, the great invention of Charles Vignoles, proudly emerges, stretching for hundreds of meters. Over 100 meters long, straight as a flaming arrow, the rail glides onto the cooling bed. The cooling process here is never permitted to happen hastily or naturally. It is a complex metallurgical phase transition from austenite to perlite, with temperatures strictly controlled by AI algorithms. The purpose is to ensure the internal crystalline structure of the steel shrinks evenly and perfectly, creating absolutely no internal stress that could cause warping during use. Once returned to room temperature, the rail dons a cold, authoritative dark gray. In the final stage, an automated ultrasonic testing machine glides over the entire surface. Invisible sound waves pierce through the solid steel core, searching for defects or microfractures even 1/10 the width of a hair. Only rails possessing an absolutely flawless atomic mass are permitted to step out of the factory doors. Let us look back on a long journey of reincarnation, from shattered, rusted drums forgotten in some dark corner of the world, bearing the destiny of an end and oblivion. But through the brilliant minds of humanity, through the silent fire of the electric arc and the molding of thousand-ton presses, they refuse to die. They have been reborn. Tomorrow, these steel tracks will be shipped away. They will be embedded into solid beds of ballast, stretching across barren deserts, piercing through eternal snowy mountains. They will carry on their shoulders millions of lives, colossal freight, and the tireless dreams of mankind. They will lie there, still and silent, enduring every storm, yet holding within them the immortal strength of time. Waste was never the end. It is merely the beginning of a far greater cycle, and that is how our civilization endlessly moves forward.